Hello and welcome. This is a demonstration video about our program. The program can be opened through the mlab file or the m file, run whichever of them. This is the interface of our program. The objective of our program is voltage control, specifically minimization of voltage regulation. The program is divided into 3 sub-programs as to cover the problem from first principles, starting with calculating the LC parameters of the transmission line, moving on to knowing the model constants and consequently the system performance, and finally the compensation value and whether it is inductive or capacitive. First program is divided to 2 sections, the inputs and the outputs. Both depend on the shape of the configuration we have. Defining the shapes. This is the first shape, single phase 2 conductors, single phase composite triangle, single phase composite square, and the inputs it needs. 3-phase bundled conductors, 3-phase bundled as well, but a special condition if the D12 is equal to D23 and D13. 3-phase triangle, which is a single conductor. After choosing a shape, say single phase 2 conductor, allowed inputs are the frequency, the diameter, and the spacing. Frequency 60, diameter 15, 0.5. Calculate. This is a plot of the configuration, and these are the outputs which are typical to sheet 2, problem 1. Trying another shape. This is the configuration shape and the outputs, and they are typical to sheet 2, problem 6 and problem 7. Moving on to the second program. Second program is divided to 2 sections, the model constants and the system performance. This is a coded program, not a simulation, from which it computes the model constants, and by knowing them, I can know the system performance. I have a short model, calculating the constant. This is the constant of the model, which are typical to problem 1 sheet 4. I have the load apparent power, the load power factor, trying the lag first, calculate. This is the values for the lag, going for lead. This is the values for lead, and they are typical to problem 1 sheet 4. Going for a different model, calculating the model constant, having a unity power factor, and I still know the load apparent power, which is 200 mega volt amperes. This is the values for the system performance, which are typical to sheet 4, problem 3. Now that I know the system parameters, I can go for the third program. This program uses Simulink to calculate the required outputs, which are either compensating reactive power using a numerical method or just a regular simulation. It is divided to 2 sectors, the compensation mode and the uncompensated mode. First sector is the regular simulation using short model to verify the authenticity of the Simulink model, but the compensation mode is for medium and long models only, which is logical as the capacitive properties of the line is neglected in the short model. Anyway, let's start with regular simulation. Going for lag power. This is the lag power values. This is the lead power values, which are typical to lab 2. Now for the main event, the reactive power compensation. The units of the transmission line parameters now depend on the length. Let's specify the tolerance for our voltage regulation. Now calculating. We can have a closer look on the Simulink file. It is trying different values. Still calculating. Recording the values and testing whether they follow the tolerance value or not. The more it iterates, the more the value is closer. Now it is over. As you see, the voltage regulation is below the tolerance value by adding approximately 10 megavars. Now let's increase the inductive load. Voltage regulation is way up the tolerance value. The values which change is the shunt capacitor and the shunt reactor load values. Still, the capacitive value of the transmission line is bigger than the inductive power value of the load. The amount of power needed is still reactive power, but it is far less than before. It's now 3 megavars instead of 10 megavars. Let's increase it up a bit. Now I need capacitive bang with approximately 17 megavars to overcome this inductive load. I hope you find this program helpful and to your needs. Thank you.